Hello, now we're moving into absolute value equations. In this problem, we'll figure out how many unique solutions this equation has without actually solving for x. Take a look at the keywords unique solutions. That's what we're determining today in this problem. Now, the equation, and take a look at it with me. The equation, the absolute value of the absolute value 4x minus 1 plus 3 equals 2 is what we are working with. Let's start with what's inside the outer absolute value. That's the entire expression, the absolute value 4x minus 1 plus 3. Now, the absolute value 4x minus 1 is an absolute value, so it can never be negative. The smallest it could ever be is 0. If I take something that can't go below 0 and add 3, the smallest it can be is 3. So the absolute value for x, the absolute value, let me get my pointer again. The absolute value of 4x minus 1 plus 3 will always be 3 or bigger. Let me show you this on a number line. We have 3. And remember, we're told that the absolute value of 4x minus 1 plus 3 will always be 3 or bigger, which is shown right here. The equation says this whole expression, going back to this equation right here, the whole expression should equal 2. But the smallest it can be is 3. It's never going to reach 2. That means there's no number we can plug in for x to make this true. What does this mean? It means the equation has no solutions. And our final answer for number of unique solutions is 0. Final answer. When you're working with absolute value equations, always stop and ask what values the inside can actually take. If it's already larger than the number on the right side, that's a quick way to see there are no solutions at all. In problem 5, we'll look at an absolute value inequality, where instead of no solutions, you'll get a range of solutions.